Yeah, good
Yes,
evening.
sir, you are audible.
So, yeah, so we are live now. Okay. So today's session is about week 3 open session. Okay. So we will be discussing the concepts of week 3. Okay, and with some examples and all. Okay. Meanwhile, how many of you have covered the content of week 3? You can raise
Yes,
your
sir.
hand.
Completed.
Okay. One, two, three, four, five. Okay, so 5 to 6 people of you have covered. What about this? It's going. I mean, uh, you're about to finish or you're about to start.
About to finish, sir.
Okay, fine. Why is there very less people have joined? Is there any session going on
No,
simultaneously?
sir, I
Hmm?
think.
Uh, okay, let's wait for some 2 to 3 minutes. Okay, let others. Let's wait for other people. After that, we'll start from 6:05. Okay, will that be all right for people? Yeah?
Yes, sir.
Okay, yeah. Hello. Okay, so let's start the session. Okay. So let me share my screen. Can you see my screen now?
Yes, sir.
Okay. Yeah. Fine. Great. Okay. So in week 3, so till now, in week 1 and week 2, we have seen joint PMF, independence of two discrete random variables, and all right conditional distributions. In week 2, we have seen function of random variables, independence, and all right. These all concepts we have covered. Now, from week 3 onwards, we will be moving to some another concepts which called the expectation of random variable. Okay, so let me write down these things. So we are going to cover expectation of random variables and then some properties related to these expectation and all right.
Yes, sir.
Okay, then next topic is some I think I mean next topic after this the
Variance.
properties of expectations. Okay, then we will be moving to the part covariance, right? I think
No, sir, variance.
variance is the
Then
next.
estimate,
Yeah,
I
yeah.
guess.
Okay, okay, yeah.
Yes, sir.
Before covariance, variance should be there. Variance is standard deviation, right?
then
Then
covariance,
covariance,
then correlation.
correlation, and inequalities, correct?
Yes, sir.
Um,
Bounds.
Markov inequality, okay, and Chebyshev inequality. Okay. So these are the topics we are going to discuss in today's session. Okay. Now, so let's start. The first topic which is called the expected value of a random variable. Okay. So first one is expectation. Now, any one of you can tell me what is this expectation or what's the need of expectation.
Gives the average mean.
Okay. Any other thought on this? What's the need of expectation?
It gives the central value, sir. In a way, it summarizes all the random variables in a single figure.
Okay. Correct. Fine. Yeah. So basically, okay. Suppose I asked, define your what is the distribution of your random variable x.
Hello,
Okay.
sir.
Yes.
Sorry, sir, but when you take a doubt, sir, after the in the last or in between
Uh,
the session, sir.
what is your doubt?
In question practice, sir. No, tutorial question, sir.
Okay, we'll come to that. Okay. Let first discuss the concept. Okay.
Uh,
Because I think some of you, I mean, only few of you have covered the lectures video. Okay.
okay,
So that's why
okay,
we
sir.
decided to discuss the concept. After that, we will discuss. Okay.
Okay, sir.
Yeah, fine. So suppose I ask, what is the describe your random variable or what is the your distribution of your random variable, right? Then what are the things you can tell me? You can simply tell me the let's say your random variable x is going to take some value x1, x2, x3 up to let's say xn. Okay, and I mean probabilities associated with each value. Let's say this is the p1, this is the p2, this is the for x3 is the p3 and up to pn and that properties with of this pmf, let's say probability should be greater or equal to 0 and sum of all the probabilities should be equal to 1, something like that, right? So that is something you can give me about I mean if you want to give the description or distribution of, I mean something information about random variable, yes or no, right? Now suppose, what if someone came to you or I asked you, suppose you are interested to describe your random variable in a single number, then how will you describe? Correct. See, rather than giving the whole description, x is going to take this value with probability this value, you might be interested to describe your random variable in a single number, yes or no?
Yes, sir.
Correct. So in those scenario, expectation is helpful. Okay. So when you are interested to, I mean it's needed to summarize the random variable into one number, into a single number, basically into one number, like instead of describing whole distribution, correct? So I need the expectation. Now, next question is how will you find the expected value of your random variable? Correct. So basically, expectation of x is nothing but it's a kind of weighted average. Okay, weighted average is basically, you can simply say how I can compute. So it's a weighted average. Weighted means this is the value, correct, for a random variable x. Yes or no? And what is the how much weight it has been assigned when x will take x1? It's a P1, correct? Plus x2 into P2 plus x3 into P3 plus so on up to xn into Pn. Yes or no? Correct? So you can generalize this summation I is equal to 1 to n xi into pi, or else you can say if you talk about in a single, so you can simply say summation of x into px. So this is something I can define the expectation of a discrete random variable. For continuous, we are going to study from V4 onwards. Don't worry about that. But for discrete, this is something I can calculate the expectation of a random variable. Is this clear?
Yes.
Okay.
Yes, sir.
So one condition is provided it should exist. Exist means it should converge. Converge means summation should be less than infinity. I mean, you might have seen some summation that is not going to. I mean that that is going to some equal to infinity, something like that. I mean, meaning that is going to diverge. So only condition is it should exist. So this is something I can calculate the expected expectation of a random variable. Let's take very simple example. Suppose I'm saying, let's say X is following Bernoulli distribution, okay, with probability P. Then what is the value X will take? X will take 0, 1, right? And what is the probability associated? So for 1, it should be P, and for 0,
P
1 minus
1
1
P.
minus
minus P.
P.
So as per the definition of expectation of X, what I have to do? Summation of X into Px, right? So it should be 0 into 1 minus P plus 1 into P. So this should be P. Yes or no?
Yes. Yes,
Right?
sir.
This is
Yes, sir.
very simplest example to calculate the expectation. Okay. So let's take another one. Let's say suppose I'm saying X is taking value 0, 1, and 2 with probability. Let's say let's make it 1 by 3, 1 by 3, and 1 by 3. Then what is the expected value of X? So it should be 0 into 1 by 3 plus 1 into 1 by 3 plus 2 into 1 by 3. So it will be 1 by 3 plus 2 by 3, which is 1, right?
Yes, sir.
Correct. So that is something I can calculate the expectation of a discrete random variable. So I think in the lecture video, sir has computed the expectation for some distributions also, right? Geometric, Poisson, binomial, and all. Okay. So do you want to do derivation that one, or is it okay for everyone? If you want, so we can discuss, or else we
It's
can
okay,
move.
sir.
Is it okay for everyone? Can you raise your hand for this?
Sir,
So please.
derivation is important for us, sir.
Uh,
Like question solving, hmm,
No, no,
like
no.
that.
The thing is that let me clear one thing regarding quizzes and all. Formula will be given to you, okay?
Mhm.
Like what is the expectation of geometric and all. But if you want or any one of your difficulty that regarding that derivation, then I can explain it.
Yes, please, sir.
So
Could you please
I
describe what
want
is
so
geometric, please?
those who want to explain to me, you can raise your hand. Accordingly, I will get some idea. So I got some 6 raise 7 8. Okay, which distribution?
Geometric, sir, geometric.
Geometric. Will that be all right for everyone?
Yes.
Okay. Yeah. So let me describe the geometric. Similar approach we can do for the Poisson or binomial also, right? So suppose expectation of geometric distribution. Okay, fine. So suppose I'm saying X is following geometric with probability P. Then what is the PMF for this? Or is I can write this one as f of x. No worries. Just a notation. So what is the PMF for this? Let's say I'm saying it's a x equal to t or k. Let's make it t for our simplicity. So what will the PMF? Anyone?
One minus p whole raised to all the probabilities without success into the final probability of success, which is
No, I want the okay. What is the meaning of this probability x equal to t here?
Sir,
it's the number of times the random
first
variable
first success will held on T, sir.
so that
First
is the
success
p.
will occur on the tth trial, right?
Yes, sir.
P
So
Yes.
trial,
first
yeah,
success
yeah.
occur tth
So
trial.
one
That means
minus p, p minus one.
What about t minus 1?
yeah, that is my question. Okay. And what will the range? Range will be t equal to 1 to up to so on, right? Now, so what is the expectation of how can I can apply expectation of random variable? It's nothing but summation of t into probability x equal to t, right? This is the definition. Expectation of x is nothing but summation of x into px, right? And range of t is 1 to infinity, correct? If you see here, from here we have 1 into infinity t and PMF. This is the 1 minus p raised power t minus 1 into p. Yes or no? So from here, p I can take outside of the summation sign because there is no any t quantity. So it will be t is equal to 1 to infinity t into 1 minus p raised power t minus 1. So now from here, what we can do, we can simply put the value of this t. Accordingly, we'll try to find any pattern or some APGP. Now, if you will put t as 1, what I will get here? 1 into 1 minus p raised power 0, right? Plus 2 into 1 minus p raised power 2 minus 1, that is 1. Plus 3 into 1 minus p raised power 2 plus 4 into or simply I can say and so on, right? So this will be the pattern. Now, so next it will be 1 and something raised power 0 means that is also 1. So 1 into 1 it will be 1 plus 2 into 1 minus p plus 3 into 1 minus p square, and next term the same pattern, it will be 4 times 1 minus p cube and so on. Yes or no? Any doubt?
Yes, sir. No doubt.
So from here, to make it simple, let's consider this as a S, because this is something we are not going to get. We are not getting any. Let's make it expression number star any pattern. So I'm going to consider this as a series X. I'm just naming it as a S. So let's make it 1 plus 2 1 minus p plus 3 1 minus p square plus 4 1 minus p cube, and so on. So to solve this or to get a pattern, what I'm going to do, if you see there is multiplication of 1 minus p, so what I will do, let's multiply with 1 minus p in this equation. If you will multiply 1 minus p in this equation, what the things you will get? 1 minus p into 1, correct? Right? That is something I will get 1 minus p plus 2 into 1 minus p square. If you multiply 1 minus p in this term, right?
Right, sir, correct.
Plus, if I will multiply 1 minus p here, then I will get 3 times 1 minus p whole raised power cube, yes or no? Yes or no?
Yes, sir. Power will
Yes,
be
sir.
increasing.
Yes,
Something
sir.
I will get, right? Now, what I can do from here, I can simply subtract the equations. Can I do it or not? So if you subtract equation number 1 minus equation number 2, then I will get S minus 1 minus P times of S equal to, so 1 minus 0, that is 1 plus 2 1 minus P minus this terminology, that means 1 minus P, correct? And 3 times something 1 minus P whole square minus 2 times 1 minus P square, I will get 1 minus P square.
Yes, sir.
Yes or no?
Yes,
4
sir.
times 1 minus p cube minus 3 times 1 minus p cube, I will get 1 minus p whole cube plus so on.
Yes,
Correct?
sir.
Now, if you see carefully, this is something I'm getting 1 plus r square plus r cube,
GP form, sir.
GP form, right? Where r is less than 1, then what is the summation of this series? 1 upon 1 minus r,
Yes.
right? So this pattern is following for this equation. So what I will get from here onwards, if you see here, I can take S as a common, right?
Correct.
Then I
sir.
will get 1 minus p equal to, so summation of this series will be 1 upon 1 minus p. Instead of r, I have 1 minus p here, correct?
Correct.
Now, so it will be S equal to, so here it will be 1
Sir,
minus
sir,
1.
this part alone, please tell once, sir.
Yeah, 1 minute, don't worry. So, okay, where? This part?
No, I got till that substitution 1 by 1 minus r. After that, how it became like this?
Okay, so instead of r, what we have? At the place of r, what we have? It's a
One
1 minus
R,
p,
R,
right?
1 minus yeah.
Correct. If you see the pattern, 1 plus r square plus r cube, instead of r, I have 1 plus 1 minus p plus 1 minus p whole square plus 1 minus p.
yes, sir.
Correct.
Yes.
Summation of this GP is nothing but 1 upon 1 minus r. Okay.
Okay.
So instead of r, 1 upon 1 minus r, at the place of r, I have 1 minus p. Correct.
Left side that 1 s into 1
Okay.
minus.
So if you see left side, what is this? S minus. Suppose I'm saying s minus r times s. So s I can take common. I will be having 1 minus r. Instead of r, I have 1 minus p, a single quantity.
Okay.
Got it?
Yes, sir. Yes, sir. Thank you.
So now here, if you see, 1 will get cancelled out. So I will be having s into p equal to 1 upon p. So from here, I got s equal to 1 upon p square. Yes or no?
Correct, sir.
Correct. So if you see, so this is the total s. This I mean.
Yes.
So this is the value of s. So it's a which is 1 upon p square. So expected value of x will be p into 1 by p square, which is 1 upon p, which is the expected value of a geometric random variable. Is this clear? Okay. The same, is this clear to all of you, right?
Yes, sir.
Okay, fine.
Yes, sir.
So similar approach you can do for Poisson, if you can do for geometric, binomial distribution and all. Okay. So other two distribution is all right for everyone. Correct?
Yes, sir.
Okay.
Yes, sir.
Okay.
So would you explain that Poisson distribution also, sir?
So do you doubt at any step, or do you want to do with the whole derivation?
So if you can do a quick one, sir.
Okay, no problem. Okay.
I'm sorry.
No problem. Okay, it's okay. So suppose I'm saying x is following Poisson distribution with parameter lambda, right? So what is the definition of expectation? So it's nothing but expectation of a random variable, nothing but summation of x into px, right? Okay. So this px means distribution of your random variable. It can be discrete, it can be continuous, but as of now we are discussing with we are dealing with the only discrete random variable. So expected of x will be, so summation of, let's make it t or k, whatever will be, let's say k. So it will be k into probability x equal to k, right? And what is the PMF for Poisson distribution? E raised to power minus lambda. Lambda is for k divided by k factor. A range of k is nothing but 0 from 0 onwards, right? So it will be k is equal to 0 to infinity. Now, if you see from k is equal to 0 to infinity, this is the k. So instead of x, I'm taking small. See, small x is just nothing but just one value of your random variable. So your probability x equal to k will be e raised to power lambda. Lambda is for k divided by k factorial. Now, e raised to power lambda I can take outside of the distribution, outside of the summation, right? Because there is no need of that thing, right? Now,
It means A is not variable, right, sir? It will be a constant.
yeah, e raised to power lambda is a constant here, right?
Sure.
Okay. So if you put the value of k, so first terminology will be 0 plus, because 0 into lambda is for 0. Okay, let me write down that one. So 0 into lambda is for 0 divided by 0 factorial. Then next will be 1 into lambda divided by 1 factorial plus 2 into lambda square divided by 2 factorial plus 3 into lambda cube divided by 3 factorial and so on, right? This is the something we are going to get. Correct? Now, so it will be e raised to power lambda.
So why the t per lambda came out?
Sorry?
T per minus lambda, how it came out before that bracket?
Not audible.
Actually, that is constant value, right? Here only k
Okay,
is.
what's the importance of keeping e raised to power minus lambda inside the summation? You can keep, no worries. But here, for all the terms, it will be e raised to power minus lambda. Multiply e raised to power minus lambda. Okay. I can take common as outside because there is no k involvement, right?
Yes,
Okay.
sir. Yes, sir. Okay,
So this
sir.
will be 0, correct? And this will be lambda plus not. Okay, so lambda plus 2 into lambda square by 2 factorial.
Yes, sir.
So lambda square or once again.
Correct, lambda square only.
Yeah, fine. Then 3 into lambda cube by 3 factorial plus so on, right? Now, if you see from here onwards, I can take lambda as a outside because lambda as a common. So I will be 1, I will be having 1 plus lambda because 2 factorial will get with cancel with 2, right? Plus then I will be having
Lambda
3
square upon 2.
lambda square upon 3 factorial, right? Plus 4 into lambda cube divided by 4 factorial, correct? Now, e raised to minus lambda into lambda, if you see a little bit carefully, so 3 into lambda square, so this 3 factorial, I can write 3 into 2 factorial plus 4 into lambda cube divided by 4 into 3 factorial. Yes or no? So from here, 3 will get cancelled out, 4 will get cancelled out. Yes or no?
Yes, yes.
So e raised to minus lambda into lambda, it will be 1 plus lambda square by 2 factorial plus lambda cube by 3 factorial plus so on. If you know the things, there is one expansion called e raised power x, okay, which is nothing but if you are going to write down e raised power x, so it will be 1 plus x square divided by 2 factorial plus x cube by 3 factorial. Okay, so this is one of the expansion. By applying this, can I write e raised power minus lambda into lambda? This will be, tell me,
e raised to lambda.
e raised power lambda, right?
Yeah.
Now, so this e raised power minus lambda plus lambda into lambda. So it e raised power 0 into lambda, which will be lambda, right? Which is the expectation of your Poisson distribution. Okay.
Okay.
The same.
And sir, like in that e power minus lambda e power. How's oh
Sorry?
for this bracket you have put e power lambda.
Yes. This is so. This is one expansion, which is something like this e raised power x. Okay. Right? Is that all right for everyone? Correct? Okay. Yeah. Okay. So, any one of you doubt regarding activity 3.1, or is this clear? Any one of you doubt in activity 3.1, or should we move? This is this one. No one?
No, sir.
Okay, no problem. Okay, then let's move to the next topic. I think next topic is some properties of expected value. Okay, so how? So let's discuss it quickly. Okay, so properties of expected value or expectation. So what is that? Suppose I have a constant. So expectation of a constant is nothing but that constant. Okay. Basically, okay, is this clear or any doubt for anyone? How you can find the expectation of a constant?
Can you explain it, sir?
Expectation of a constant is constant. Huh?
Yeah, it's a basic thing. Suppose I'm saying x is going to take value only 2, for example. Okay, then what will be the probability for this 2? 1, because x is taking only one value, right? Yes, no?
Yes, sir. Yes,
So
sir.
what will be the expectation? X into px, 2 into 1, which is 2. Instead of 2,
Yes,
let's
sir.
make it a constant, right?
Hmm.
Clear?
Yes, sir.
So this is the something expectation of a constant is nothing but that constant.
Constant.
Another is expectation of, let's say I'm saying a into x. Then what it will be? So it will be
A into expectation.
expectation of x. Okay. You can do for you can derive for anything. We are just discussing the properties. Okay. If you will derive, you will get the same value. You can do for the, let's say for this property, for this case, expectation of x was 1 right here, correct? Suppose I ask expected value of 2x. So this should be same as 2 times of expected of x, right? As per the property,
Yes.
correct?
Yes.
So expected of 2x will be what? So it will be 2 into 0, right, which is 0. It will be, so what are the values will be 0, 2, 4, correct, for 2x. Yes or no? So it will be 2, it will be 4, it will be 2 plus 4, which is 6 by 3, which is 2, right? Expectation of 2x. Now, this is the same as 2 times of expectation of x,
Yes.
equal to 2 into expectation of x was initially 1. Is this clear? Okay. So you can apply the this things. Okay. So third property is, suppose I'm saying expectation of x plus y. This is same as expected value of x plus expected value of y. Okay, this is the one property you can keep in your mind for any kind of two random variables. For any kind of two random variable means it doesn't depend whether x and y are dependent or independent, irrespective. So for any kind of two random variables x and y, this will be the true. Okay. Fourth property is, suppose I'm saying, okay, you people will tell me what is the expected value of ax plus b.
A is expected of
And
Expectation of
expected value of
x
x
plus b.
plus b.
So basically, first of all, I can write this is expectation of ax plus expectation of b, right?
Yes, sir.
So but if you see the second property, I can simply write a times of expectation of x, and expectation of constant is nothing but that constant. Correct?
Yes, sir.
What about expectation of ax plus by? So it will be
expected A
correct,
into A.
b into expectation of
Y.
Y.
this is something we can apply, right? So I forgot to mention one thing, properties of I mean not properties, actually expectation of function of a random variable. Okay, so which is the, I think we have done for this example, expectation of 2x. So this is same as if you want to find the expectation of gx, which is function of random variable. So this is same as summation over x gx into probability at x equal to x. So suppose we want to find the expected value of 2x. So this is same as summation x over x. So this is the function of a random variable. It will be 2x into that PMF or probability associated with each value. Okay, is this clear? Yes, no, any doubt?
Yes.
Okay,
No doubt, sir.
fine. So I think next one is the
Get
variance.
this function.
Sorry.
I didn't get this E of gx. I'm somehow not able to understand that.
Okay, did you get the things which I will just calculated expectation of 2x?
2x is
Just a few seconds before I have done expectation of 2x, this thing for this example. Did you get how I have computed?
0 2x.
You didn't get, I think. No problem. See, tell me if x is any random variable. So can I say 2x is the one of the function?
Okay.
Can I say x plus y is the one or x plus 2 is the one of the function? Something.
Yes.
Correct. So this gx I'm talking about function of random variable. It can be
Okay.
anything. Okay.
Okay.
So how I can define the expectation of x? This is nothing but summation of x into px, right? So instead of x, if I have function of that random variable, so I will simply put that function.
Okay, got it.
Got it? Okay. Yeah. Now, so I think next topic is variance, right? Okay. So how we can define the variance? Variance is nothing but, so defined as expected value of x minus mu whole square. This mu is nothing but expected value of my random variable. Okay. So if you will expand this formula, right? So you will get expected value of x square minus expected value of x whole square. Okay. So this is something we are going to compute for the variance. Why we are interested in variance? Anybody?
To understand the spread, like what is the variability in the random variable?
Okay.
Variance from the average.
Variance from the average. Okay, fine. Okay, suppose let me take one example. Suppose I'm saying there is two colleges, college A and college B. Okay, and there are some. Let's say I'm talking about annual packages of some 5 randomly selected student. Okay, so all packages are in lakhs. Okay, now what will be the average of these things? 30. Correct?
30.
And for this also average is 30 lakhs.
Yes.
Yes, sir.
Now, suppose can I say performance of or I mean uh, annual package of in both colleges is the same?
No. No, sir.
See, even though averages are same, right? But by I mean through only one average or one single value, see, we can get some central idea. Yeah, average annual package in university A or college A is 30 lakhs, and average annual package in university B is also 30 lakhs. But is the, I mean, in the reality, performance are same? I mean, or the students are same?
No, sir.
No.
No,
No, sir.
right? So, which university you will prefer?
B, sir.
B.
B.
Why?
B.
Because there
Because
is more consistency, right? There is less variability, correct? Yes or no? Suppose
yes,
so you will prefer the students of university B, right, instead of university A, correct? Why? Because there is less variability, correct? Yes, no, are you getting my idea,
yes,
right?
sir,
What
but
I'm
there
trying.
is a less variability. Yeah,
Hmm.
it may be constant B, but sir, in A there is also a higher chances, right?
Had chances of what?
Like
Yes,
value,
like
like yeah.
we are trying to get how it is distributed individually.
No, no,
How
no. So thing is, my what I'm trying to discuss here. Suppose you have two things. Okay. Suppose you have two college or two things.
Sir,
Or,
I think we can think like a class average as a student marks. That will give better picture.
correct,
Maybe.
correct, correct, correct. Yeah, that is something. Suppose you have two class. Okay. Let's say T1 or let's make it class 1 or class 2. Okay. Okay. Suppose in that class you are some this is the marks of some 5 students. Okay. And in class 2 this is the marks of some 5 students. Yes or no? Okay.
yes,
Now, which students you will prefer?
C2.
Why?
All are equally, getting same marks.
Means somehow there is consistency, right? There is less variability in the marks of class B, class 2 something, right?
So
Yes,
there
right.
is no variability, sir. They are constant, sir.
That is I'm trying to explain
No, no, like you are
which
trying to
one will
say like
okay.
how the difference between every student.
Correct,
Got it.
correct. So here I'm trying to explain where is the less variability. You are going to prefer that one. That is something we can prefer in general itself, right?
Got it, sir. We can
Yes,
assume
sir.
it
Yes,
like
sir.
for the
Yes, sir.
Ha.
variance.
So that is something I was trying to explain here. So even though mean is the same, but we are interested to know how much variability is there in my data set. How I can check? We can simply check x minus mu, correct? If you will expand, if you will apply the formula here, a minus b. Okay. How many of you know this derivation part, or should I do?
Sir, if sums are discussed, it will be very useful, sir. Like,
Okay. Let me. Sorry, sums of.
if sums are discussed, it will be very useful. This
Okay. Okay.
formula and all correct, but we don't know how to do the problem correctly. We don't get answer.
But
0
sir, at
marks.
real time, we are struggling with questions like
Okay, okay,
that.
I will come to that. No problem. See, this is x minus mu whole square. This is the one of formula, right? See, in stats one and all, you have seen population variance and all how we are defining 1 upon n summation of xi minus x bar is square, right? We are going to check the deviation for each observation from its mean, right? Here I'm talking about the random variable. The things is the somehow same, correct? If you apply there a minus b whole square, I will get x square plus mu square minus 2x mu. Yes or no?
Yes, sir.
Yes,
If
sir.
you take
Yes, sir.
expectation inside the bracket, what I will get? Expectation of x square plus expectation of mu square minus 2 mu expectation of x, because mu is the constant, right? So it will be expectation of x square. Here I will get mu square minus 2 mu. Expectation of x is mu, right? So here I will get x square plus mu square minus 2 mu square. Now expectation of x square minus mu square, right? So if you see, here I got expectation of x square, and what is mu? Mu is nothing but expected value of x, right? Whole square. So this is the another form of variance of x. You can use either one, but mostly we are preferring this one because this is something helpful. I mean, both one is the correct, but this is the something I like it. Okay, let's do one problem. Okay, so if you see for x 0, 1, 2, right? So what was the probability? 1 by 3, 1 by 3, 1 by 3, correct? And what was the expected value of x? How will you compute? First of all, expectation of x?
X into P of X.
X into?
P of
P of X.
Right?
Equals to
0 into 1 by 3, 1 by 1 into 1 by 3.
So basically it will be
It is 1.
0 into 1 by 3 plus 1 into 1 by 3 plus 2 into 1 by 3, which is nothing but 3 by 3, which is 1, right? Now we got this quantity, correct? Next is I to compute expected value of x square, correct? So how I can compute expected value of x square? First of all, compute what is the x square will be. So x square will be 0, 1 square 1, 2 square of 2 is 4, right? Yes or no?
Yes, sir.
What will the probability?
Yes, sir.
Probability will be the same.
1 by 3, 1 by
1
3.
by 3, 1 by 3,
Hmm.
right? Then now what will be the expectation of x square here? It will be
0.
0 into 1 by 3 plus 1 into 1 by 3 plus 4 into 1 by 3, which is nothing but 5 by 3.
3. Yes, sir.
I have this quantity. I know what is the variance. Variance is nothing but expected value of x square minus expected value of x whole square. So what is the expected value of x square is 5 by,
5 by 3
5 upon
minus
3.
and what is the expected value of x is 1 square. So it will be 5 by
Square.
3 minus 1. So if you see, this is nothing but 2 by 3.
2 by 3.
Okay, is this clear?
Yes.
Okay, this is something you
Yes,
can
sir.
simply compute. First, you can see what is the expectation of x and what is the expected value of x square. I mean, the thing is you have to keep in your mind the formula one. That's okay.
So first distribution will be given, right? Like x and probability of x will be given in this kind of problem.
Only then you can compute. Otherwise, how can you compute? Unless it has been mentioned. Suppose I'm saying x is following. Suppose, okay, for example, suppose I'm saying x is following Bernoulli P. Okay, then find the variance of x. Okay, then you have to calculate everything. Okay, let me do it for now. Okay, so if
Please,
then
please.
from here you have to identify if x is Bernoulli P, that means x will take value 0, 1, correct? Yes or no?
Yes.
What is the probability? It will be 1 minus p and p.
P.
For this, what is the expected value of x? 0 into 1 minus p plus 1 into p, which is p, right? Now, this expected value of x you have. What about expected value of x square? If you see x square, then 0 square will be 0. Again, 1 square will be 1.
Yes, sir.
Same probability, right? 1 minus p, p. So what is the expected value of x square? It's a summation of x square into px, right? So if you see 0 square into 1 minus p, or I have directly 0, so 0 into 1 minus p plus 1 into p. Again, I got p, right?
Yes, sir.
So what is the variance of x from here? It will be expected value of x square minus expected value of x whole square. So it's a p minus p square. So p I can take common, p into 1 minus p, which is the variance of Bernoulli random variable. Now is this clear how you can compute the in with the problem?
Yes, sir. Yes, sir.
Fine, you got the idea, right? Okay, it can be any kind of distribution. Your x can be anything. Your what I told your I mean, accordingly probabilities can be anything. It can be anything. Okay, fine. Should we move to the next topic? Is that all right? So far, so
Yes,
good.
sir. Yes, sir.
Sir,
Yes, sir.
it means distribution will be not changed, right? X values will be constant. Just probability will be changed, right, sir? So we have to.
Probability will change or values will change. How you can change the probability?
No, it will be given in question, right?
It will be given in question. Yeah. Either it can be given your x is going to take value this. I mean, you can simply say, suppose there are two kind of question. First, I can simply say x is following Bernoulli P. Tell me the variance of this random variable. Then you have to think what is the value of x, because it's a Bernoulli distribution, right? Or else what I can do, I can simply say x is going to take some value. Let's say I'm saying x is going to take value -1, 0, 1, or let's say 2, and with the probability 1 by 4, 1 by 4, 1 by 4. Then I ask what is the variance of x. Okay. Yeah, okay. So all of you have pen and paper right now?
Yes.
Yes, sir.
Okay. Just take 2
Yes,
minutes
sir.
and tell me what will the variance of this random variable. Then we will be having idea whether you got the question or not. Okay. Yeah. You can take 2 minutes, no problem.
अरे भाई तो ये
5/4.
5/4.
5 by
5/4, sir.
okay. Let's cross check. How many of you? Okay. So first of all, as per the definition, I have to see expected value of x square minus expected value of x whole square, right? Now first let's find the expectation of x. So what is this? This is nothing but summation of x into px, right? So it will be -1 into 1 by 4 plus 0 into 1 by 4 plus 1 into 1 by 4 plus 2 into 1 by 4. So this will be 0 and this will be -1 by 4. So here it will be, this will get cancelled. Basically, I will get 2 by 4, right? Now, expectation of x square will be, I can simply direct write down x square into px, right? That means -1 square into 1 by 4 plus 0 square into 1 by 4 plus 1 square into 1 by 4 plus 2 square into 1 by 4. So if you see here, I will get 1 by 4 plus 0 plus 1 by 4 plus 4 by 4, right? So here from where I got 6 by 4, correct? Now, what is the variance? Variance will be expected value of x square, that means 6 by 4 minus 2 by 4 whole square, right? So 6 by 4 minus 4 by 16, that is 6 by 4 minus 1 by 4, okay, which is 5 by 4. Okay. Is this clear to all of you?
Yes, sir.
Yes, sir. Got it, sir.
No, you got now how to compute this, how can compute, right? Okay.
Even if
Yeah.
you reduce the
Yes,
same
sir.
answer only, we'll get this, sir. Oh, 2 by 4, 1 by 2. Okay.
Okay. Yeah. Okay, so next topic is covariance, right? Covariance. Now, tell me, any one of you can tell me what's the need of covariance?
Variance for two variables.
Okay.
To check the association between two random variables.
What
How are
kind
they
of
related?
association?
If one is increasing, then what the effect of it on the another? Is it increasing or decreasing?
Okay, so I mean, I'm talking about what kind of relationship?
It is
Linear, sir.
yeah.
Ha, correct. So basically, covariance tells us the to know the it. I mean, it will basically give you the linear association between two random variables, two numerical variables. Basically, that is something we are going to. Now, this is very similar to variability. variability is for one variable and covariance for two random variables. Now, how my variance of a random variable is defined as expectation of x minus mu whole square, right? Or expected value of x square minus expected value of x whole square, right? So covariance between two random variables is defined as expected value of, if you see this is, so x minus mu, instead of mu, let's talk about mu is what? Expectation of x anyway, right? So x minus expectation of x into y minus expectation of y. Can I do this? Yes or no?
Yes, sir.
Yes, sir. Yes, sir.
Now, if you see this formula, so it's the same as expectation of x into y
Sir,
minus.
once tell that, sir, how that came. X minus E of
Okay,
X.
what is this x minus mu whole square?
The previous formula, E of X square
Ah,
minus.
that is something I'm trying to explain. First of all, tell me this is the expectation of x minus mu whole square. This is something variance is defined, right? Correct. So this x minus mu whole square, can I write x minus mu into x minus mu? Instead of x, I have x minus mu, let's say y minus, instead of mu, let's say mu dash. Because this mu is expectation of x, correct? So now instead the same thing, mu expectation of x, mu dash expectation of y. Clear?
Okay, sir.
Okay, fine.
Thank you, sir.
Yeah. So this is the same as this formula. Okay. If you will put, let's say y x in place of y, I will get expected value of x into x, right? Minus expected value of x into expectation of x again. So this is the same as expectation of x square minus expected value of x whole square or not, which is same as variance of x. Correct or not? Are you getting my point? Okay.
Yes, sir, getting.
Getting?
So can you
Fine.
yes, again?
So now from here, so there are some properties. So this covariance, first of all, this covariance can be positive. Okay. See, variance will always be positive. Variance cannot be negative. Okay. This covariance can be negative. Okay. And this covariance, if it is 0, then I will say x and y are not linearly related. Okay. Can any one of you tell me in which scenario this covariance will be positive and covariance will be negative?
Yes, sir. When x square will be greater than, then it will be negative. So greater than ex power whole square.
Greater than, see, we are not talking about ex square. I'm talking about this terminology.
Okay.
X is more than y.
Say this x increases, y will increase. Then it is a positive
Correct.
correlation.
Basically, if you see covariance is expectation of multiplication of these two, right? Okay. So that means I can say x minus expected value of x into y minus expected value of y should be greater than 0. It should be positive, right?
Yes, sir.
Correct. Same. So when it will be positive, both are okay. If x is greater than this, y is also greater than this, right? Okay.
Yes.
Let me tell you one more thing. After that, I think it will be clear. Okay. So suppose I'm going to draw a line. I mean, line means that plot. Okay.
You are saying like that it will be linearly related, right, sir?
Yeah, that is something covariance tells us actually. Okay, let me
It
draw.
goes like a straight line, sir.
One second. Let me draw something. Okay. Suppose this is the case. Okay. For example.
So sorry to interrupt. In this, the different form you given, right? Which is the standard form that we kind of?
Both one is okay. No problem. You can use any one. Okay. But mainly, see, this is just nothing but this formula you can get if you'll expand this one. You can try it also. Okay. The same thing we got this formula by just expansion of this one, right?
Right.
The same thing you can get the second one by the expansion of the first one, but the second one is preferable actually. I mean, because it's something easier to calculate. Means you can simply multiply here. If you can simply calculate the expectation of x, right, y, then you can simply multiply the value of these two and something that a joint probability, right?
Okay.
Okay, that is something. Okay, let me tell you something. Suppose I'm saying, for example, suppose this
Can
is
you
the,
please go again that formula of covariance?
okay.
Yes, sir, done.
After this lecture, this PPT will be available, sir.
Sorry.
After the lecture, the PDF will be available for us.
We'll share on the portal. Okay.
Okay, thank you, sir.
Okay, what I was about to discuss something. Yeah, no worries. Let me start. Okay, so suppose this is the something. Now you will give me an idea. This is suppose your x random variable. This is something y random variable. And for example, suppose x bar is somewhat is lying here, and for example, let's say y bar is here. Okay, so I will be having some. Let's say I have some these 4 coordinates. Okay, and these are the some values and all relationship between these. Okay, now tell me what will be the value of xi minus x bar here, less than 0 or greater than 0?
Here, greater than, okay.
What will the value of xi minus x bar here in this coordinate?
It is less than 0.
Less than 0.
Less than 0.
Ah.
What about y minus
Yes,
yi minus y bar?
Greater than 0.
Greater than 0.
Yi minus y bar?
Negative, sir.
Less than 0.
Less than 0. How it can be greater? It's this. See, this is the y bar, right?
Correct.
Correct.
Yes,
Okay.
yes.
What about this coordinate? Xi minus x bar?
Positive. Yes, sir. It will be positive.
Greater than 0.
Yi minus y bar?
Less than 0.
What about this?
Both are 0.
Both are greater than 0.
Both are greater than.
0.
And what about this?
Why
X
would be
Less than
Negative.
less than 0 and other one is greater than 0.
Positive.
Now, if you see in the covariance, what we are seeing, if you see in the covariance formula, covariance between x comma y is nothing but expected value of x minus expectation of x into y minus expectation of y, right? Correct? Means if you see in single value xi minus x bar, yi minus y bar, right? Correct. Now tell me, what about product of these two? What about xi minus x bar into yi minus y bar? What will be the product?
positive, sir?
Positive.
Here,
Negative.
here,
Positive.
Positive.
positive, right? For this,
Negative.
now you got the idea. When it will be negative, covariance will be negative, and variance will be positive. Sorry, covariance will be positive.
Yes.
Correct? Can I say when see I have two things, right? X minus expected value of x, right? Into y minus expected value of y. Correct? When when covariance will be positive, when can I say x is above its average? Correct? Above or below its average? Correct? Same. Y is also above and below its average or not?
Yes.
If you see, x is if below its average and above its average, product is going to be positive. Same for y. Yes or no?
Yes, sir.
Correct? And this will be the positive. Correct? In this case, when if this is the above, y will be also above and below its average, right? Is this clear? Now, when covariance will be negative, when it will be negative,
X above, Y below.
correct? Basically, I can say if x is above, or let's say I'm saying below its average. Okay, this is suppose this is something. Then y is below or above its average, right?
Yes.
It's clear? Okay, fine. Yeah, this is something I was just trying to explain. Okay, tell me if covariance tells us the linear association. If I will say covariance between x comma y is 0, that means
No
I will say
relation.
X and Y are independent.
Uncorrelated.
I will say X and Y are independent, yes or no?
Right.
Okay. If I will say X and Y are independent, then can I say covariance between X comma Y is 0?
No, sir.
Okay, let me clarify first thing. Second one is the correct, first one is the wrong. Okay. Because X and Y are independent, means there is no relation, then covariance will be 0. If covariance is 0, only then I can say X and Y are not linearly related. Okay. It can be related somehow. For example, it's possible, suppose X is there, Y is defined as X square, then covariance between X comma Y can be 0. But in reality, these two are not independent. There is a relationship. Is this clear? Covariance tells us only linear association between two random variables. Is that clear?
Yes, sir.
Okay.
Sir,
So,
one doubt.
Hmm.
So earlier we learned this covariance and variance in a different form, right? How is it different, like in random variable and the stat one the formula,
No,
like X?
things are the same. See, in stats one and all, if you see the formula, see, things are the same. There, we are doing just for us, some specific values. Okay, if you see covariance, I define summation of xi minus x bar into yi minus y bar, right?
Right.
Okay, the
Right.
same thing we are doing here. Correct?
Okay.
Where, see, there we have some small quantity. So suppose I'm saying, okay, suppose I'm saying x is taking some 5 to 6 value, y is taking some 5 to 6. Tell me the population covariance.
Right.
Correct. So anyway, we are going to do that. I will simply say x is something value, some value is taking, right? I don't know about the probability. Y is taking some value. I will say simply covariance, find the population covariance between these two. I can simply do 1 minus n summation of xi minus x bar, yi minus y bar, right? Correct?
Right.
Here we are talking about probability associated with each values as well. Okay. So if we see the formula carefully, so it's nothing but expectation of x minus expectation of x, right? Y minus expectation of y. See, these two are the same, right? Anyway, correct?
Right.
Okay, so yeah, so that this part is clear, independent at all, because sometimes people get confused. They are treating both as the same. Okay, but the first one is not true always. Second one is the true. Okay, so we are saying x and y are independent. Okay, so you have seen the independence concept in the previous weeks, right? If x and y are independent, then I will say covariance between x comma y is 0, right? This is true. If covariance between x comma y is 0, that means expected value of x into y minus expectation of x into expectation of y, this should be 0, correct?
Yes, sir.
So expectation of x into y, this should be equal to expectation of x into expectation of y. Okay. If x and y are independent, then I will say expectation of x into y, which is the same as expectation of x into expectation of y. Is this clear?
Yes, sir.
Okay. One thing I forgot to mention in the variance case, properties of variance. Let me clarify that. After that, I will move to this part. Okay. So properties of some variance. Okay. So what is that? What if I will say variance of a constant? Let's say a. What will be the variance?
A.
Square.
Okay, a. Someone say a square. Okay. Anybody else?
0, sir.
0. Okay, who told 0?
Me, sir, Rajiv.
Raji. Okay, yeah, it's a correct actually. So thing is that okay, expectation of a constant is that value only. Okay. In case of variance, okay, if you are saying something, right, so just think a little bit. Variance of a constant, whether it will be that value, no, because variance is defined as expectation of x minus mu square, right? So variance of a constant a, expectation of a minus a, that will be 0. Yes or no?
Yes, sir.
Correct. So variance of a constant will always be 0. Okay. Tell me variance of a times x.
A square variance of x, sir.
So it will be a square variance of x. You can simply keep in the formula. So variance of ax will be expected value of a square x square minus expected of ax whole square, right? Correct.
Yes, sir.
So from here you can take I square as a common. You will get expected x square minus expectation of x whole square, and which is nothing variance of x. Now tell me variance of ax plus b.
Yes.
A square
That's
variance of x
variance.
plus b, right? Correct.
No, sir. No,
There
sir.
should not be b because variance of b will be 0. Okay.
Yes,
Now
sir.
tell me what about variance of x plus y?
Sir, variance of
Variance
x
of x plus variance of y.
y minus covariance of,
Not minus plus.
yes, covariance
So
of
this is
x.
something we are getting actually in case of you remember in case of expectation of x plus y will always be same as expectation of x plus expectation of y irrespective of I mean it's true for any kind of random variable whether x and y are related, dependent or independent or not. But in case of variance, if you will do this case, right? So this is the expansion formula. Unless if x and y are independent, then covariance will be 0, right? In that case only variance of x plus y should be same as variance of x plus variance of y when x and y are independent. Is this clear?
Yes, sir.
Okay.
Yes, sir.
Yeah. Now come to the properties of covariance. So I'm just going to write. I'm not going to in the derivation part. Okay. Properties of covariance. Okay. So what about I think we have seen covariance of x comma x is the same as variance of x, right? Now tell me covariance of x comma y. Will this be same as covariance of y comma x? Okay. So
Yes, sir.
due to this property, we are saying covariance is the symmetric actually. Okay. And third one is some linear quantity. So suppose I'm saying covariance of x comma a y plus b z, for example, then how will you proceed? It will be simply a times covariance of x comma y plus b times covariance of x comma z. Okay. And tell me what about covariance of, suppose I'm writing ax plus by comma z. Tell me, it will be a times covariance of x comma z plus b times covariance of y comma z. Okay. So this is something you can keep in your mind. Okay. Anyone do you doubt how can compute covariance and all from the joint PMF table, or is this all right? How you can compute?
So please take an example.
Okay, let me go. I think covariance has been discussed. I think activity 3.5. Okay. So, okay, let's do this question number 2. Okay. Will that be
Okay,
all
sir.
right? Okay. So first of all,
Yes.
if you see, we have to compute the covariance between x comma y. That means it should be expectation of x into y minus expectation of x into expectation of y, right? So first of all, I have to compute this. I mean, I have to compute all the quantity, right? Let's make it equation number 1. So what are the values? So 0, 1, 2, 0, 1, 2. Okay. So x is there, y is there. Anyone can tell me value 0, 1, 2, 0, 1, 2. Okay. So what is the probability for 0, 0? So 1 by 12, 3 by 12, 0. 1 by 12, 3 by 12, 0. Okay. Then 2 by 12, 0, 1 by 12. Fine. Then 3 by 12, 1 by 12. Okay. Now, so be careful little bit. Careful means, okay, if you see, so this will give you the x of x, right? Joint PMF, right? Not x, it will give you y, correct? and this one will give you the joint of, sorry, marginal of x. So what is the fx of, so if we have to add all this probability, right? So it will be 6 by 12,
Yeah.
and here 4 by 12, and here 2 by 12, right? Similarly, here it will be 4 by 12, 3 by 12, and 5 by 12, right? Totally. Now, so if you see, first of all, I to calculate expectation of x, right? This means summation of x into fx of x, right? So summation of x means you have to multiply. We have to do these things. We have to do 0 into 6 by 12 plus 1 into 4 by 12 plus 2 into 2 by 12. So this is something distribution of x I can compute, right? Yes, no, any doubt?
Yes, sir.
Is this clear?
Yes, sir. Clear.
Yes, sir.
So basically it's a 0 into
8 by
0 into 6, 6 by 12.
0 into 6
0
by
into
12.
6 by 12. Huh?
One
Okay,
into 12.
plus
Plus 1 into 4 by 12.
plus
2 by
2 into 12, 2 by 12. So it will be 6 by 12, right? Sorry, 8 by 12, right?
Yes.
Now, same, what is the expected value of y? So we have to do, if you see expected value of y, 0 into 4 by 12 plus 1 into 3 by 12 plus 2 into 5 by 12, right? So 0 into 4 by 12 plus 1 into uh, 3 by 12 plus 2 into 5 by 12, that is 13 by 12, right? Now, if you see expectation of x into y, that means what? We have to do summation of x into y into joint PMF, right? Yes or no?
Yes, sir.
So we have to little bit careful, because if you see what is the value, 0 into 0 into this probability, okay? Don't take this or this one, because this is the joint probability for this value and this value, right? So it will be 0 into 1 by 12 plus, let's fix it for first row. So then 0
0, 1
into 1
into 1,
into 3 by 12.
3 upon 12. Yes, sir.
Everyone is getting how I'm taking the values, right?
Yes, yes.
Then 0 into 2 into 0, right? Correct? Plus. Next is, let's talk about row number 2. So 1 into 0 into 0 by, sorry, 2 by 12. I'm directly writing it 0. Will that be all right, right? Because 0 into 0, right? Then 1 into 1 into 0. Again, it will be 0. Correct? Plus 1 into 2 into 1 by 12. 1 into 2 into 1 by 12. Plus 2 into 0 into this thing. It will again be 0. Correct? Plus 2 into 1 into 1 by 12. Plus 2 into 2 into 1 by 12, right? So this is 0 0 0 0 0. So we have, anyway, we have 2 by 12 plus 2 by 12 plus 8 by, sorry, 4 by 12. Total is 8 by 12, right? Correct?
Yes, sir.
So covariance is what? Expectation of x into y minus expectation of x
expectation of
into
x.
expectation of y. So it's a 8 by 12. Expectation of x is 8 by 12 into 13 by 12. So 8 by 12 I can take common. It will be 1 minus 13 by 12, which is nothing but 8 by 12 into minus 1 by 12. Okay. So it will be no. So minus 1 by 18. Right? Is there any option? Yeah. B option should be the correct. Okay. So is this clear how you can compute the covariance and all?
Yes, sir. Clear.
Yes, sir.
Fine. So I think next topic is correlation, right? Correct? Correlation. Now, any one of you can tell me why we are moving to the correlation, and what does this covariance tells? Sorry, correlation tells us.
So it will give the what is the strength of correlation?
Okay. What do you mean by strength?
Strength meaning like is it a weak correlation or strong correlation? Let's say that the value is more than 7.75, so you can say that it is a very strongly correlated. Value is
Okay.
So one
yeah.
one
How
will affect
related
the
to
other.
variables are?
Yeah, height and weight, sir.
How
Okay.
one affects
It
the
gives
other.
measures, sir.
Okay. Yeah. Any other thought?
How one affects the other.
Yeah, that is the meaning of association. That is something we have seen in covariance. So if you're talking about association only or relation, so if covariance already tells me the linear association between two random variables, then why we are moving to the correlation part?
Sir,
That's my question.
because it's unitless, sir. While
Okay.
covariance is not unitless, that's why it's get a better picture of the association.
Okay, fine. Okay, yeah, somehow, more or less everyone gave the correct answer. Okay, it's a unitless measure and it give me the strength is also one of the very correct answer. So basically correlation something, okay, tell me it's the strength is very correct answer. So, and unitless. So these two are very important things. So if you see, okay, first of all, tell me if I will talk about covariance x comma y. For example, I got covariance between these two is 152 and covariance between these two is let's say 70 and covariance between x comma y let's say 170 for example and covariance between x comma y is let's say minus 180 and covariance between x comma y is minus 52. Okay, so which one is the strong positive or moderate or something? Anyone by seeing the value can we give any idea? See, yeah, can we
170 is strong.
how we can decide the 170 is the strong?
Can't
The
be
height.
decided if whether
Correct.
if
Because yeah, you can decide
Yes.
only when see here we know this is we can simply say this is the positive association is there negative, but how much we don't know, right? We don't know what is the strength of that association. Yes or no? Correct. Yes or no? So basically
Yes, sir.
in the correlation this correlation gives me the strength of that association because correlation lies between minus 1 to 1. If correlation between these two is very close to 1, I will say strong and positive, and it's very close to minus, or I will say strong and negative association is there. Yes.
yes,
And
sir.
also, this correlation coefficient is unitless measure. Okay, it's a very important thing. Unitless measure. How? So that's why this correlation coefficient defines. So, this is the row of x comma y. Some people denoting r x y. No problem, but we have to keep the mind this formula. This is the defined as covariance between x comma y divided by standard deviation of x into standard deviation of y. So if you see, suppose x is let's say age and y is weight, okay. Then what will be the unit for covariance and x comma y? It will be age, sorry, year into kilogram, correct?
Yes.
And for standard deviation x, again it will be year, and for y it will be kilogram, right? If you see, unit will get cancel out, right? Yes or no?
Yes, sir.
Okay, so that's why this correlation coefficient is unitless measure and range is minus 1 to plus 1. Okay, is that clear now? Okay, so to compute the correlation and all, you can simply, you know how to compute the variance. You can simply calculate the sorry, what to say, that covariance, variance, and you know what is the standard deviation. Yeah, I forgot to mention about standard deviation. Any one of you can tell me what's the use of standard deviation of any random variable? I think these are all things we have done in statistics one.
Well, root of the variance.
I don't, okay.
It is the exact unit.
Variance of x.
Okay, why we are taking root?
And it is deviation from the central value, sir.
That is something variance already tells me, right? Deviation from the central value. What's the need of standard deviation? My question is this. If suppose I'm saying variance is 4, then what's the importance of taking square root of 4?
So it's making the same unit as
Correct, correct,
random variable.
correct. Because it gives me the same unit, because as the original data set, then it's easier to compare. For example, x is, let's say, that age. Okay, then variance you will get, let's say, 14 year square, for example. Correct. If you take the square root of this, square root of 14 year, then this is the in year, your original data is also in year, then it's easier to compare, right? Okay, so far so good. Yes, no.
Yes, sir.
Okay.
Yes.
So basically, both gives the
Yes.
Yeah, both will
how
give you
far
the variability from your
correct.
data set. The thing is, we are taking square root of so that I mean we can get the variability in terms of original unit. See, if this is, suppose I'm saying variability is 2 year, okay, and your original data is also in year, then it's easier to denote the things, right? Correct.
Yes, sir.
Okay.
Yeah.
Yeah. So just give me 1 minute. I'll be back. I will connect my laptop with the charger. Okay. Hello. Can you hear me?
Yes, sir.
Okay, fine. So next is something bounds on probability. Okay. How many of you covered the all the lecture video till this inequality? Lecture 3.7. Yeah, some of you are going to raise hand. Yes. Okay, you have covered, right?
I have not covered.
I mean, Vivek, Rajesh, Sudhir, Ripu, Sudan. Yeah.
Yes.
Okay. Okay.
Yes, sir.
Now, can you tell me why we are interested to know the bounds?
Sir, we are not interested in calculating exact probability, knowing exact probability. We just loosely interested in the knowing the how far it go beyond the its average value probability. That's
Okay. Correct. And others?
Sir, it gives the boundary how the probability it less than or greater than this value.
Okay.
Yeah, it gives kind of maximum and the lowest. Maybe something like if we think of insurance data, like the company may be interested, like I'm just trying to correlate that
Okay.
if they give this money, yeah.
Fine. So yeah, That's correct. Let me give one example. Okay, before going to, let me define this. First one is Markov inequality. First of all, by the nomenclature, if you say it's a bounds on probability, we are interested to know what can be the upper bound, what can be the lower bound for that probability. But why we are interested in the bounds? Why not in the exact probability or something like that? Okay, let me tell you. First of all, let me define this Markov inequality. Suppose I have a discrete random variable x, okay, which is taking non-negative value, okay, which is taking non-negative values, let's say with a finite mu. Finite mu means that mu should be exist. I mean, it should be less than infinity, okay, with a finite mu, which is the expected value of x, okay. Now, then Markov inequality has been defined as probability x greater or equal to c less than or equal to mu by c, where c is the constant. Now, okay, tell me, suppose, okay, now you will get idea. Suppose I'm saying x is following, let's say, binomial distribution with parameter n comma p. Okay, instead of n comma p, let's say it's a 5 comma half, for example. Okay, then if I will ask what is the probability x is greater or equal to 3, then how will you compute? I can compute probability
5
x equal
upon
to 3
3.
plus probability x equal to 4 plus probability x equal to 5. That is something we have to do.
Yes, sir.
But we can
I can
also do 1 minus
I can
probability of x.
do, okay, let me explain what I'm trying to explain here. I can do this one, correct?
Yes, sir.
Yes or no? Right. This is something I can, from here, if you will solve 5c3 half raised for 5 plus 5c4 half raised for 5 plus 5c5 half raised for power 5, you will get something value. Let's say I'm assuming at the x. This is something I can get the exact probability,
Yes, sir.
right? On the same page, from here, I can calculate probability x greater or equal to 3 less or equal to mu by c. Okay, what is the mu? Mu will be 5 by 2, which is 2.5. See, mean of the binomial distribution is NP, right?
Yes, sir.
So it will be 2.5 divided by 3, right? Yes or no? You are getting what?
Yes, sir. Yes.
So basically, I can compute a bound, means this probability cannot exceed this quantity. This probability will always be less than or equal to this.
Yes, sir.
Or I can simply calculate the exact probability, right? Both I can do from here. So far, so good.
Yes, sir.
Now, tell me what here, if you see, I give,
Can you please tell the consequence?
sorry.
Can you once again tell it?
Okay, so there is one Markov inequality which is defined as probability x greater or equal to c, where c is some constant less than or equal to mu by c. C should be basically greater than 0. Okay. Now, if I will ask, suppose I'm saying x is binomial 5 comma half, then what will be the value of probability x greater or equal to 3? Before applying this Markov inequality, I can simply calculate the exact probability. Probability x equal to 3 plus probability x equal to 4 plus probability x equal to 5. Correct? Right?
Yes, sir. Yes, sir.
I can find, right? I can simply, if you apply the PMF of binomial, this will be something. So I'm not going to calculate the exact value. So let's assume this is x. Okay. So here, from here, I can calculate, I can find the exact probability. Exact probability means not bound. Correct? I can find the exact value here. Right? Now, if you will apply the Markov inequality, then probability x greater or equal to 3 will be less or equal to mu. Mu is what? Mu is nothing but expected value of x. And in case of binomial distribution, expectation of x is n into p. Here we have n as 5, p as half. So it will be 2.5. Correct?
Yes, sir.
So my mu will be 2.5 divided by 3. Right?
Yes.
Correct. So this means what? This means this value, this probability x greater or equal to 3 will always be less than this 2.5 divided by 3. It cannot exceed this value. Okay. If you
So the 3 is the number which is given in the
yeah,
question.
this is the 3 number, huh? Correct.
Okay.
Here it means if you will calculate the exact value, right? this will always be less than or equal to this quantity. Okay. Now, just let's change the scenario. Suppose in this case, initially we had the information of x is following binomial distribution. Now, what if I will say, let's say I'm saying x is, okay, let me write down one scenario. Suppose, suppose that it is known, known that the number of items, okay, produced in a factory, okay, during a week is a, let's say, random variable, okay, is a random variable with mean 50. Okay, that's all I'm saying. Next question is what, let's say I'm asking what is the probability that this week production, okay, now here what is the my x? X will be number of items produced in the factory, right? Yes or no? I can define or not?
Yes,
Yes, sir.
Right. Then what is the probability that x will greater or equal to 75? Means in a particular week, what will be the probability that this week or in a particular week production will exceed 75 or will be at least 75? Now, can you tell me here, can you calculate the exact probability value of this probability? Can you calculate the exact value?
No, sir.
No.
No, sir.
Why? Because we don't have the information what kind of x variable is, whether binomial, Poisson, geometry, we don't know, right? Correct? So in such scenario, it's useful if you don't know the exact probability, I can simply calculate the bounds for that by using the Markov or Chebyshev. I mean, for Markov, only mean is involved. We'll move to the Chebyshev. But here I can calculate the, let's say, the probability that x will be at least 75 is less than or equal to 50 divided by 75, right? I mean, mu by c, right? So mu is 50 in the question and c is this quantity. Is this clear? Correct. Then
Yes, sir.
these
Yes,
are
sir.
the helpful, right? If you know the distribution, you can calculate the both. But if you don't know, you can calculate only bounds.
That example you told, right? The exact probability and the Markov's inequality. Can you scroll little up? Why you are telling that two? It cannot exceed the 2.5 divided by 3.
How will we, how it will exceed?
So
Because
you
see, this bounds only tells me this probability x will be greater or equal to c, less or equal to mu by c. That means this probability will always be less than or equal to this quantity, right? See,
okay.
see, this 2.5 by 3 is the upper limit for this case. Okay. This
Mm-hmm.
exact value you can calculate or you can cross check. Okay. This exact value will always be, okay, let's do it right now. So 5c3 will be 10 plus 5c4 will be 5 plus 1 divided by 2 raised to power 5. So that means 16, 16 by 32. This is half, correct? Just cross
Yes,
check whether it's
right, right.
correct or not. Okay. So what is the 2.5 by 3? This is something 0.8, correct? 0.83 something, right? And 2 point half is 0.5, right? Here exact probability is 0.5, but it's a less or equal to 0.83, right?
Yes.
Now is this clear?
Yeah, okay.
Got it, right?
Yeah.
Okay, yeah, fine. So then you don't know something about distribution and all, then this is the very helpful. Okay, let's move to the Chebyshev inequality. So Chebyshev inequality is just an extension of the Markov inequality, basically. So why it's important? Because in the, if you see the Markov inequality, only mean is useful. I mean, we are going to use only mean here. We'll be moving to the variance also. Means information. Let's x is the x be a discrete random variable. Okay, with mean mu and variance sigma square. Okay. Then Chebyshev inequality. Give me a minute. Okay, so Chebyshev inequality is defined as, so it's nothing but probability modulus of x minus mu greater or equal to k sigma less or equal to 1 by k square. Okay, don't worry, I will tell you how we can get this. Okay, so basically, if you see the Markov inequality, what is this? Markov is more probability that x greater or equal to mu less or equal to mu by c, correct? Where x is taking non-negative values only, correct? As per the definition, right? Yes or no?
Not really. It's confused. Huh?
Sorry? Where,
X.
okay, if you're
Okay.
getting
Okay.
confusion any point, right, you can tell me rather than just watching the things. Okay. So
Okay. This is
basically,
the earlier one, na probability.
yeah, this is the Markov inequality. Okay.
Okay. Okay.
Okay. I'm trying to explain it how we can get this Chebyshev inequality through Markov inequality.
Derived from that. Okay.
Okay. So this is
Okay.
the Markov inequality. So here, if you see, uh, x is only going to take only non-negative values, right? So if if I will replace x as the x minus mu whole square, can I do? Sorry, it's not a mu. No one is corrected. It's a c. See, if x is non-negative value, if x minus mu whole square will take non-negative value, right? Correct?
Yes.
Correct. This c I can replace with the k square sigma square, because c is also positive. Then k square sigma square will be positive. Yes or no?
Yeah.
See, as per the definition, x is going to take only non-negative value. If I will replace x as x minus mu whole square, it will also take non-negative value.
Yes.
Yes, sir. It gives positive.
C is the greater than 0, then if I will take k square into sigma square, where sigma square is the variance will always be greater than 0, right?
Yes.
So k square into sigma square will always be greater than 0.
Yes.
Yes.
Right? Now,
Yes.
if you will put in the above inequality, so probability in the place of x, I will take x minus mu whole square greater or equal to, okay, so in the place of c, I will be having k square sigma square, right? Okay, let's do, I'm not writing down this right now. I will write at the end. So probability, okay, if this is case, can I write modulus of x minus mu greater or equal to k sigma?
Yes, sir. After removing the square.
Okay, so basically, if you see, what is this? Less or equal to expected value of x minus mu whole square, right? Okay, first of all, this is the mu by c. So this mu is what? Expectation of x, right?
Yes,
so
sir.
here, if you see, this is the expectation of x minus mu whole square. See, what is the Markov inequality? This is the Markov inequality, right? So instead of this mu is expectation of x, right? So instead of x, I have x minus mu whole square. Instead of c, I have k square sigma square. So mu divided by c. So which is mu? Mu is
Yes, sir.
expectation, right? So this divided by c. So far so good,
Yes, sir.
right? So if you see probability that modulus of x minus mu greater or equal to k sigma less or equal to, what is this? This is nothing but variance of x, right? Fine. So from here, if you see probability that modulus of x minus mu greater or equal to k sigma less or equal to sigma square divided by k square sigma square, right? So here, if you see, k sigma square will get cancelled out. So I can simply say modulus of x minus mu greater or equal to k sigma less or equal to 1 by k square, which is the Chebyshev inequality, right?
Yes.
Now, so there are two forms of Chebyshev inequality actually. Both are useful. I will tell you in which scenario which one is the more useful. So first form is this one, probability which we have discussed, modulus of x minus mu greater or equal to k sigma less or equal to 1 by k square. Okay. Another form is probability that modulus of x minus mu less than k sigma greater or equal to 1 minus 1 by k square. Actually, these two are the forms. If you see, so sometimes you can see the questions whether you have to find the upper bound or lower bound. So what kind of bound is this? And what kind of bound is this?
First one is
Sir,
your
upper bound and second one is lower bound, sir.
So this is the upper bound. Upper bound means this probability will always be less than this bound. This is the upper, this is the maximum value, right? This probability cannot exceed this value, correct? Whereas this quantity, second one, if you see, this is the greater or equal to this quantity, this is the lower bound. Means this probability will always be greater or equal to this quantity. Okay, so these are the two forms of Chebyshev inequality. Is this
Sir,
clear?
can you please take an example on
Yeah, I will
this?
give you. I will give. Don't worry. Don't worry. I will give you example. First of all, let
Okay.
me try to explain this upper and lower. Okay.
Yes, sir,
Now,
got it.
in which scenario these two will be helpful? First of all, let's see this one. Okay. If I have probability modulus of x minus mu greater or equal to k sigma. Okay. Let's see the second one very first. That will be helpful. Let's see the second one. Okay, so this, if you expand this second one, so can I write this as minus k sigma less than x minus mu less than k sigma? Yes or no?
Yes, sir.
Yes, sir.
I can write, right?
Mm.
See, how means, suppose I say mod of x is less than 2. Can I write minus 2 less than x less than 2?
Yes, sir. Yes.
Got it now?
Yes, sir, got it.
Okay, now. So if this is the case, suppose now, so from here, I can add mu on both sides. So I will get mu minus k sigma less than x less than mu plus k sigma greater or equal to 1 minus 1 by k square. Yes or no?
Yes, sir.
Right. Now,
Yes,
if
sir.
you see this form a little bit carefully, so if you have been asked the probability something lie between something a and b, I mean your axis will lie some between a and b, then you have to always calculate the lower bound. Okay, right?
Yes, sir.
Okay, let's see the this formula, very first formula, upper bound one. You have probability. Okay, let me write down this here. You have probability modulus of x minus mu greater or equal to k sigma less or equal to 1 by k square, right? How I can expand the middle part? If x minus mu greater or equal to k sigma, so can I say x minus mu greater or equal to k sigma, or x minus mu will be less or equal to minus k sigma? I can write, right? Correct? So if this is the case, so can I write x is greater or equal to mu plus k sigma, or
Yes.
x is less or equal to mu minus k sigma? Yes or no?
Yes, yes.
Right. So this is the or thing. So I can simply write probability x is greater or equal to. Okay. So this is the case, right? So you have to careful whether what kind of things you have been asked. Okay. Let's see the this question part. Okay. In this question part, suppose this is the random variable with mean 50, and suppose I'm saying with mean 50 and variance 75. Sorry, 25. Okay, suppose this is the case. Okay, let me write down the question here itself. Suppose I'm saying x that this week production with mean 50 and variance is, let's say, 25. Okay, now suppose question is what is the probability that this week production will be between 40 and 60? Are you getting my point? So how will you write between 40 and 60? Correct?
Yes, sir.
Right? Everyone is getting. Question is that week's production in that factory have the mean 50 and variance is 25. Question is what is the probability that this week production will be between 40 and 60? So far so good.
Yes, sir.
Now we have to find the bound. Now if you see this is the similar kind of this one, correct?
Yes, sir.
Yes or no? So here from here mu minus k sigma will be 40, right?
Okay.
Yes or no? Or mu plus k sigma will be 60. Anything. Let's go with the mu minus k sigma. So what is the mu here? 50. So basically to compute this bound, I have to calculate the value of k. Correct?
Yes, sir.
Then first of all, then what is the mu? Mu is 50. What is the sigma? Sigma is 5, right? Because variance is 50, 25, so variance sigma will be 5. So from here it will be 50 minus 40 equal to 5k.
How you got that 5, sir? 5.
See what is the variance?
Oh, okay. Sir.
Correct. So from here 5k is equal to 10. Correct. So k is 2. Right? Yes or no?
Yes, sir.
So from here what will the bound? It will be greater or equal to 1 minus 1 by 2 square, that is 4. So this probability between 40 and 60 will be greater or equal to 3 by 4.
Yes, sir.
You can calculate this value of k with this also. I mean mu plus k sigma is equal to 60. So 50 plus 5k equal to be 60. Again 5k will be 10. Anyone is the fine. So the key thing you have to keep in your mind which formula you are going to use. If it's asking about between, then you can use this formula. Right? Is this clear?
Yes, sir.
So can you please show upper one formula, sir?
This one?
Yes, sir. Wait 1 minute, sir, please.
Okay.
So like how to decide which formula we have to use? Can you tell it once again, sir?
See, that's why I told you. First of all, see, sometime it is, it will,
At
listen.
last you said 2 lines.
Should I complete? Okay. So what I'm saying, see, there is some background noise. Okay, yeah, thanks. Okay, so if you see, first of all, you have to keep in your mind, sometimes it will be mentioned whether you have to find the lower bound or upper bound. Okay. If you have been asked about lower bound, that means you have to use this form, correct? Means
Yes, sir.
x minus mu less than k sigma. If you will expand this, then you will get this case, right?
Yes, sir.
Correct.
Yes, sir.
So if you see here, that means your x is lying between two value, right?
Yes, sir. All these things.
Correct. Here, if you see, my question was my x will be lie between 40 and 60. That means it will be greater or equal to 1 minus 1 by k square. Got it?
This only, sir. How we have to decide? We have to use 1 minus k square. There is also one formula 1 by k square.
See that 1 by k square you will get when x is greater or equal to something or less or equal to something.
Okay. So based on the question, we have to decide which
Yes.
form.
You can't. Okay? If you will do less than or equal to 1 by k square, it's totally wrong, right? Got it?
Yes, sir.
See
Thank you,
this.
sir.
If you see this case, right, modulus of x minus mu less than k sigma. If you will expand this one, right, so I can get mu k minus k sigma x minus mu less than k sigma, right? So this right hand side is the same anyway, right? So I got this form by this one. Okay. Okay.
Just asking out of curiosity, not asking you to derive this. How did this, like the mathematician derive this formula? Like how did the, I mean,
Nice question.
Which one? Less than or equal to, greater or equal
no,
to?
these two formulas, like the Markov's inequality and Chebyshev's inequality. How did they derive this? Like, I mean, based on what they told that this is the theorem or formula?
Okay. First of all, Is this scenario clear or
Yes,
not?
scenario clear.
Scenario clear, right? In this case, we cannot calculate the exact value, right?
Right.
Right. So for that, we must be if we cannot calculate any exact value, then we must know some bounds, right? This should be less than or this should be greater than, right? Correct.
Right.
Now come to the very first Markov inequality. We are not going to in that depth. First of all, no one asked why we are using the mean only, why not median and all. Yes or no? This mu. Okay, so there is a logic behind it. We are not going into that depth and all. For this foundational course, we are just going with the inequality itself. We are not going to from where it came and all. If you want, I can simply do the things on we can discuss on the discourse itself, right? We can derive and all. Okay.
Yeah, sure. I'm
Sure,
just
no problem.
asking.
Okay. So because see, there is a logic behind it. So no one asks why mu is there, right? Why not median? Why not something else? Why not, correct? That might be a question, right? Why mu is only, right? So we can discuss Markov. Now you maybe I am hoping you got the how we got the Chebyshev. We got the Chebyshev through the Markov, right? See, for the
Yes.
Markov, if only mean is there, you can use. What about if variance is also given to you, correct?
Sir, it is basic inequality, sir. Base.
Yeah, it's a basic. The question of Biplo is correct from where we got and all. So as of now, we are not going into that one. Okay, but we can discuss on the discourse and all, right? Okay.
Yes, sir.
So, but there is logic behind it also, right? Why mean is there only? You have seen that probability x greater equal to c less or equal to mu by c, right? But why mean? Why mu? Why not something median? Why not some variance? Or why not, let's say I'm asking expectation of 2x? Why only expectation of x? Correct. So we can discuss that one later also. So okay, first of all, tell me, these two forms are clear for everyone?
Yes, sir.
Okay. Now let me take the one question from activity and all. Maybe that will give you some.
Sir, can you take, sir, tutorial question? It's also cleared. Also cleared the topic.
I will come to that one. Don't worry. Don't worry. Okay. Tutorial has already solutions, right? I think. Okay. Okay, no problem.
Activity doesn't have explanation. The problem with activity question is we don't know how it is coming, the answer.
Okay. Let's do question number 3. Okay. I want to do the I want to explain the another form. Okay, if you see the question, suppose a fair coin is flipped 200 times, right? Then find an upper bound. Here it's clearly mentioned you to find the upper bound on the probability that number of times the coins lands on head is at least 130 and at most 70. Okay. Okay, tell me, it has been asked, first of all, n is 200 times, right? That means x is number of heads, right? So that means x will follow binomial 200 comma half. Yes or no?
Yes, sir.
Okay. What will the mean? We need mean, which is NP, which is 200 by 2, which is
100.
And we need
100.
variance NP 1 minus P. So 100 into 1 minus half, that means 50, right? Now, if you see carefully, what is the question? Question has been asked. We have to find the upper bound. That means it should be less or equal to. Okay. Forget about less or equal to. It should be says at least 130 or at most 70. What do you mean by at least 170? 130?
Greater than equal to.
X is greater or equal to 130?
Sir, like how
or
that? Sorry, sir.
X
Sorry,
is
sir.
yeah.
Sorry for disturbing, sir. That sigma square, how, sir?
What is the variance of binomial distribution?
N into P. Oh, formula.
Right? N into P into 1 minus P. NP is 100. See, this is the N, right?
Yeah,
This is
that.
the P.
Okay, half of 200.
Correct? Got it? Yeah.
Thank
So question is at least 130 or at most 70, right? And we have we have seen one form, x is greater or equal to something or lesser equal to something, less or equal to 1 by k square, right? So x is greater or equal to mu plus k sigma or x is less or equal to mu minus k sigma is less or equal to 1 by k square, right? This is the form we have to use.
Yes, sir.
If even though it is not, see, in the question is clearly mentioned upper bound, right? So that means we have to use this form. If it's not mentioned, can I identify which bound I have to use, right? Correct. For this question, I have to find the upper bound, right? In the previous one, if you see, question was between 40 and 60. In that case, we had to find the lower bound. See, this form is helpful only for lower bound.
Okay.
Okay, and this form is helpful for the upper bound.
Yes.
Okay, are you getting the idea, right?
Yes.
Okay. So from here, what is the, okay, I have to compute the anyway it should be less than or equal to 1 by k square. So I have to compute the value of k, right? So if you see, mu plus k sigma is 130, mu minus k sigma is 70. I can use any one. Let's take mu plus k sigma is 130, right? So here mu is what? 100, correct? K and sigma we have computed how much? It's a square root of 50, right? Yes or no?
5 root 2, sir.
What is the square root of 50?
5 root 2, sir. Wow.
Sir,
2 root 5, sir. 2 root 5.
2 root 5. 2 root 5 or 5 root?
No, 5 root 2, sir. Sorry. 5 root 2, sir.
Okay, tell me the final value of square root of 50.
25 into 2,
2 root
25
5,
comes
sir.
out 5 root 2.
5 root 2.
No. I'm asking the final. Okay, let's make it root 50.
7.07.
1 second. So it will be 130 minus 100, right? Which is 30, right? Correct? So value of k will be how much? 30 divided by square root of 50, right? So if you will put the value of k here, so you will get 900 divided by 50. So it will be less or equal to 50 divided by 900. It will get 1 by 18.
Yes, sir.
Yes, sir.
Is there any option? 1 by 18. Let's check this one. So 1 by 18 is the correct. Okay. So there are two forms which you have to keep in your mind, right? So one is for upper bound, one is for lower bound. Okay. So whenever it is okay, so let me write down again. So x minus mu less than k sigma greater or equal to 1 minus 1 by k. So which is, what is this? This is the lower bound, right? If you will expand this case, so we got probability mu minus k sigma less than x less than mu plus k sigma greater or equal to 1 minus 1 by k square, right? So if there is something where it has been clearly mentioned between, x is lies between something, we have to find the lower bound. Or second form is so whenever is the and one what is the second one? Probability that modulus of x minus mu, okay, which is greater or equal to k sigma less or equal to 1 by k square. So if you will expand this, so I will get probability x is greater or equal to mu plus k sigma, or x is less or equal to mu minus k sigma. This would be less or equal to 1 by k square. So these are the two forms you have to keep. If you see this inequality carefully, so here x is lying between something, right? Some two value, and in this case x is greater than equal to something and x is less or equal to something. Is this clear? Yes,
sir.
no, any doubt?
Yes, sir. Yes, sir.
Is that clear, right? Okay.
Yes, sir.
Yeah, so I think we have covered the content, right? Someone was asking questions from tutorial.
Yes, sir. Me, sir. Vivek.
Which tutorial?
Sir, tutorial 1, sir.
Okay. So we have done from the content, right? I think I'm hoping
Yes, sir.
everyone got the idea.
Yes,
Okay.
sir. Yes, sir. Thank you, sir.
So we can, if you want, then
Do a quick revision before we attempt GA.
Sir,
Hi.
like in the website official, where this PDF and all will be available, sir?
This session
Can
PDF.
you show? Can you show in that?
Okay, so you can take it from just go under the supplementary content, okay, and you can find. Meanwhile, I will send
Last
you.
time, no,
One second, one second, one second. I will send in the Google chat itself. Okay, you can access right now. Okay, just I'm not able to here paste. Is that, why is that?
Sir, in the portal site, can you show us where we have to search? Probably later we'll search.
Sir, can I leave this
You can
mail, sir?
you can find from the supplementary content. It's not uploaded yet. We will upload there. Okay. Okay. Yeah. Under supplementary content, you can find extra things. Yeah. So in yeah. So okay. So yeah, Vivek, I will come to that. So you have only one doubt or anything else?
Is there anywhere somebody has demonstrated activity
Sir, can I
questions
leave
or
this
sometimes we
meet
get an
because
activity
the
questions?
One by one, please. Yeah, please go
sir,
ahead.
can I leave this meet
Yeah.
because
We have
the
done. We
next?
have done. We have done. We are
Okay,
done.
sir. Bye, sir. Good night, sir.
Good night. Yes, yes. I think Radha, right?
Yeah.
Yeah. Please. Yeah.
Sir, is it anywhere activity questions are explained? Because sometimes we get stuck while solving it.
So you can ask, right? If you're stuck somewhere, you can simply ask in the session or in the discourse and all, right?
Okay.
TA session is there. So there is no solution for activity. I mean, no solution means no solution PDF. Activity question is just based on your video lecture. Okay.
Okay.
So we are not providing some solution PDF because that is something you have to little bit think, you have to little bit try. Okay, Vivek, tell me in which question you have to doubt. So we have done. Let me clarify. We have done. So those who want to stay, they can stay, or else you can leave. Yeah, Vivek, tell me in which question you doubt.
Sir,
no
question
doubt.
number
I mean-
first
Huh?
And question number 5, sir. 5
What
or
is-
6, sir. Sir,
what is
I'm
your-
not able to find the mean and variance, sir. Every time I find I will
Yeah.
got
So
certain,
what is doubt in question number 1? So have you seen the solution?
no, sir.
Why?
Where
Solution
is
is there, right? You can, if you see, if you click on the, let me clarify, if you click on the check answers, right, then you will get the solution below every question.
Okay, I will handle it, but you can describe the question number 5, sir. How will
Question
it
number 5. Okay, let me clarify. Solution is there. If you still you are getting difficulty, right, then
No,
we can discuss. Yeah, no problem. Okay. Yeah. In question number 5, it is asking about dependency, right? Independence, right?
Which are you open, sir? Tutorial 1, sir.
Yeah, tutorial 1 are you open?
Week 3.
Week 3.
Yes, sir.
Yeah, it's in front of my screen. Can you see my screen?
Maybe he's asking activity.
No, I opened week 3 tutorial 1, not graded.
What is your question? Tell me.
Uh, Find the probability that fx is at least one standard deviation away from its mean.
One second. One second. Let me see. Maybe it's in week tutorial 2.
Not this one.
Okay, this
Yeah,
one. Okay.
yes, sir. This one.
Okay. So what's the problem?
Sir, how it do it symbol like probability of x less
Okay.
than or greater than
See. What is this? What do you mean by at least? It should be greater than.
Greater than, yes, sir.
Correct.
Greater than.
So find the probability fx is at least one standard of deviation away from its mean, right? So
Yes.
at least it should be greater than, right? So it means your x minus mu. See, away from its mean, its mean. That means x minus mu greater than sigma.
Greater than sigma. Any key is value of 1.
Sir, greater than or greater or equal to?
Yeah, sorry, greater or equal to k sigma.
Okay.
Sorry, greater or equal to sigma only. You are talking about question number 5, right? So 3. Yeah, you can simply say it's a greater or equal to sigma, right?
Yes, sir.
Clear?
Where the value of k is equal to 1.
Great value of k is equal to 1.
Okay.
Okay, fine.
Okay, sir.
Okay. Yeah, so if you click on the check answers, right, so you will get the solution below every question. Okay.
Okay,
Just
I
try
don't
out.
know that.
No problem.
Sir,
No problem.
Okay.
sir,
Yes.
I have
Yes.
a small doubt in question number 8, activity question 3.2.
Activity 3.2. Okay.
Yes, sir.
Okay.
Question.
No problem. No problem. Let me go. Okay. In which question? Question number 8.
8. Sir, 8.
Okay. What is your doubt?
My doubt is, sir, here, sir, I have checked the x and y are independent. I've calculated the value and found x and y are independent. And if I put this formula in the expression, if I calculate e of z equal to e of x square plus e of 3 into xy, then, sir, my doubt is, can I write e of x square in terms of e of x whole square?
No. How?
Because,
Okay.
sir,
You are talking. No. See, expectation of x square is different from expectation of x whole square.
but sir, here x and y are independent. Does it not make?
No, x and y are independent, right?
Yes, sir. X and y are independent.
No, how you can say x square is same as?
Okay, actually, sir, I was just writing e of x square, e of x into x, and thereafter I was just expanding it, e of x into e of x. I
Okay,
think
so
it's
you are saying expectation of x into y. You are saying expectation of x into expectation of x, right?
Yes, yes, sir,
Then you
yes,
are
sir.
saying expectation of x whole square. I don't think it should be correct.
Yeah, yes, it's not correct.
Yeah.
Actually, I'm not getting the answer by writing this.
No, it's not the way. Because see, anyway, if just a thing, you my screen is visible? No.
No, sir.
Okay.
No.
So you can simply think. Suppose I'm saying x is following. Let's say. Okay, let's say x is taking value 1 and 2 with probability half and half. Okay, then expectation of x will be 1 into half plus 2 into half. That means 3 by 2. Correct?
Yes,
if
sir.
you will talk about expectation of x square, then it will be simply 5 by 2. It's not the same, right? X is because whenever you are taking x square, that means that random variable will take the different value. Okay, it's not about the same value, right? If you're talking about two different x and y, that is the different case.
Okay, sir, got it.
Yeah. Okay, then is that all right, everyone? Okay.
Thank you, sir.
Okay. Thanks everyone. Okay. Bye. We'll meet in the next session.